Nuon is now part of Vattenfall, and this power plant is a very valuable asset in the Vattenfall portfolio because it's firing gas, and it is also capable of later on firing coal.
We're mainly building everything under the ground except the cable works and all builders work above ground. So in fact we connect the Mitsubishi turbine to the world.
I see Ballast Nedam not only as a pure construction company but also as a service provider.
Because Ballast Nedam already know Mitsubishi way of thinking, that's why we feel that Ballast Nedam is much closer to Mitsubishi comparing with the other European company.
We discuss a lot of things on a nice way with each other. So you intend to solve problems quick, and really enjoy that.
We work with a limited amount of subcontractors because most of the disciplines we have in company. That means that we have a long time relationship with all our people. We can train them in safety awareness and project management skills, and they form the basis to a successful project. Our goal is to have a satisfied client. If the client's not satisfied, we don't have a satisfied project.
Ballast Nedam is especially strong in cooling water systems. On that we have a very particular situation here, that we are very near to a nature protected area, and Ballast Nedam was thinking together with us about the solutions for this system.
All of the design works are carried out in cooperation with our client Mitsubishi. These works consist of the cooling water intake, the cooling water outflow, and the design works for the cooling water piping.
We combined our schedule with the 3D model. You see that here. So we have the 3D model of the complete project. And we connected our schedule to the 3D model. So you get a 4D model or a BIM model, or building information model. And then you get a kind of movie for the complete building project. So if the schedule gets modified, our simulation is also modified. Now you can see who is working where, at what place.
Well, I think it's the experience of Ballast Nedam to keep the planning. They know how long things last.
So it's my responsibility to make sure that every aspect of the job gets remeasured in a coordinated, controlled and standard way and format. My personal goal is really to make sure that all the works on site are transferred from the drawings into these small baby packages, so everything's clear, so that we can present it to the client and the contractor and hopefully get everything agreed. And overall, we have around about 400 or 500 individual packages.
Those people are capable and know what they are talking about. Of course, price is always a discussion, but that is typical for such a project as this. Very difficult items in this project was the cooling water outlet, because the water flows into the Waterzee, which is a protected nature. And so we wanted to have a very compact cooling water outlet. So we had to work together with all kinds of parties to discuss about how the cooling water outlet should look like. And Ballast Nedam was a facilitating, a service providing partner in that.
Ballast Nedam Engineering works together with Deltares to design the cooling water outfall for the Magnum power plant.
We model this setup here to determine whether the structure is stable and can withstand a certain design storm. We will measure the waves and also we measure the damage, which is the goal.
We have the W-shaped walls here, so it can flow nice and easy into the Waterzee. My personal goal is a clean understanding between execution departments and the engineering departments.
Well, this GRP pipeline is the main cooling water line for the Nuon power plant. As you can see, the pipe is made out of glass force reinforced polyester. We do the basic engineering and the detailed engineering of the GRP line. Ballast Nedam does the engineering of the installation. So we work very closely together in the field of engineering.
Talking about the quality aspects dedicated to the GRP piping, it's very important to have the backfilling done by proper compaction. The thickness of the layer is about 30 centimeters, which is quite a lot of work for us to be done if you talk about 4 or 5 kilometers of length in total.
This pipeline has to be hydro tested and pressure tested, and this is done by Ballast Nedam, also in cooperation with us.
Building which will take in the water which is required for the cooling. In the intake building itself there will be a lot of other systems which will take out the debris. There will also be a fish return system, that's some sort of a band screen which will take out the fish, and it will take care that they will re-enter the water safely.
One of the additional items we had to deal with, and also Ballast Nedam had to deal with, was at the cooling water inlet. We had damage there caused by a third party, and that damage would totally destroy our commissioning schedule. So we had to go for an interim solution, which gave us a very big profit in the schedule. And if we would have insisted on having the final solution, we would have a delay of 3 months. Now we had, through the thinking of the Nuon team and the Ballast team, we have found an interim solution which only caused a delay of 1 month.
Well, safety is always important, of course, because we all want all workers to go back home safely and that they not get injured or hurt in any way. The chance of fatalities is there. We live with safety all day, that's our job.
The roof sheets are to be installed during the night hours. This because of the safety during the daytime. We have a lot of workers underneath the roof, so it is very dangerous to work above those workers. The cladding, what you can see, is made from Duracell wood sandwich panels. It is not solid concrete. Those are specially made for reduction of noise. The turbine is resting on the concrete table. Talking about the concrete table, that is a very accurate piece of concrete which is having tolerances more close to the mechanical world rather than the civil world. We have a lot of controls and checks and a lot of extra people involved for measurements, accuracy, the anchor bolts, the holes, the conduits and all kind of installed steel metals. The turbine is not lifted on top. The turbine is sliding on a horizontal skid coming down from the outside world inside the building itself.
Of course, Mitsubishi is a manufacturer of turbine, so for us the installation of turbine is one of the major milestone dates for the power plant construction. And it was in April we successfully installed the first turbine, so that's why we arranged that our Japanese style, so-called the Shinto style ceremony, which we used to do in Japan, and I really wanted to introduce in this country.
It is extreme different to work with each other because of the mentality and culture. For that reason, we adopt cultural training courses here on site with all staff members.
Anyway, installation of turbine is just a starting point for us to start the mechanical work. So the meaning of that ceremony is to expect the safe execution of the following work. We have to know there is a difference. Then, based on this understanding, we have to find some solution. Okay, so that is what I learned in this project. I have to work like this way. I understand it is very important to understand each other because, as a fact, the way of thinking is a little bit different in the Japanese and the European people. I believe that schedule-wise and quality-wise, we are satisfied with ballast Nedam.
When we look to the civil part, we are about 95% ready. It looks good.
And you can see clearly now that the mechanical and electrical contractors have taken oversight. We are reducing staff now, and we will come back at the end of the project to do the finishing works.